Hey everyone, in this video we're going to be looking at load combinations and we're going to do an example. So shown here on the left side we have this structure. It's a portal frame and we're told that the structural analysis for this steel portal frame has already been completed. Alright, and we have the results of that analysis on the right side here. And we got load patterns for dead, roof, live load, snow load, wind load, all right? And we're told that these are unfactored bending moments for the column base moment on the right side of the frame. So the numbers in this table here on the right, these are the values from the structural analysis, probably performed in, SAP 2000 or some kind of structural analysis program. And we're asked in bold here on the upper right, to determine the maximum factored moment, or M subscript F, for the moment base connection according to the ultimate limit state requirements of this long code CSA A23.3-2014 version. All right, so we need to check both positive and negative moments, but this is our task. Find MF according to the Canadian concrete code. So for some, this might seem quite daunting, okay? We have, all this stuff on the left side here, and we're asked for the ultimate limit state load combination. We need to find the governing ones, and we know there's a lot of different combinations that we could have. But the important thing to realize here is that the structural analysis has already been done, okay? This makes the question actually pretty much a slam dunk, but we'll go through the motions of it so we can see just how simple it actually is. All right, so in summary, all this stuff on the left, these pictures, they're great, they're fantastic, but they're not actually needed to solve the question. All we need is these 6 numbers here. So let's take a look at all the load combinations in chart form and figure out which ones apply, which ones we need to investigate, all right? All right, let's start by taking a look at the Canadian code load combinations. So this table is actually taken from the National Building Code of Canada, but it can be found reproduced in Annex C of the Canadian Code, which is called A23.3. It is similar to a table found in ACI 318. ACI 318 is the American Concrete Code. Well, there is a difference between some of the load factors, or the numbers that appear before the D, L, S, and W. Another difference is that the American code calls the roof live load LR, and the Canadian code, you're just assumed to separate it yourself. It's just referred to lumped in with the L, okay? So we're going to be using the CSA code, or the Canadian Standards Association code, for this one, which references the NBC, and we need to make a few observations. The first observation we can make is that the snow load can't act with the roof live load, all right? So this is the same as the American code. We don't assume that maintenance is being performed on roofs while the snow is there. So S1, which is the first snow load, being greater than the roof live load, we can actually neglect the roof live load, and we can neglect S2, the other snow load, because S1 is greater than the other two. All right, we can only have one snow load acting at a time. Another observation is that the wind load, number 1, is small, so we're going to consider it only as a companion load to S1 in this case, the other load that's producing a positive moment. So we always have a principal load, which is the dead load and one other load, and then a companion load, right? So W1 is going to be a companion load to S1. So for the positive moment, if we're gunning for a positive moment, trying to figure out what the worst positive moment is, MF, at this base moment, we should consider the very first load case, 1.4D, because the dead is pretty high in this case, and we should consider this 1.25D plus 1.5S, in this case S1, plus 0.4W. In this case, that's W1. So if we do the math here, 1.4D, we get 104.3 kilonewton meters. And if we do the math on this second positive moment load combination, 1.25 dead plus 1.5 S1 plus 0.4 W1, we wind up with a value a little bit greater at 162.8 kilonewton meters. So the second one is the governing positive moment. So we see that was pretty simple. We only needed to investigate 2 positive moment cases. For the negative moment, we took a look at W2, and we noticed that it is the only load that is causing a negative moment at the base moment. Okay, so it needs to be principal. We need to use W0.9D because the dead load is counteracting, and we can see there's no other companion loads because none of them can contribute negatively. Doing the math on this negative moment case, we find our answer to be negative 46.6 kilonewton meters. So we were able to produce a negative moment at the location. And voila, we've solved our 2 governing load cases, positive and negative. So that really wasn't that bad, wasn't it? Don't be scared of load combinations. Use your brain. Don't go through the whole table one by one, right? Use your brain to eliminate possible cases so that you only have to investigate a few. And often you might have a hunch about which one's going to govern just based on the numbers. All right, stay tuned for some more concrete examples. Excuse the pun.